Welcome back to Master the PLC Programming. Myself is Nitin from Autosys, and today we are going to see one short rising OSR instruction, that is also called as positive edge instruction, one short following OSF instruction, that is also called as negative edge instruction, and then we are going to do the actual demonstration with Allen Bradley PLC. Now here the input changes from 0 to 1 and it will remains the high for next 5 scan cycle. Just for demonstration purpose, I have shown the scan cycle and given the number from 1, 2, 3, 4, 5, 6. And then after 5th scan cycle, input goes to low and it will remains low. Now the OSR instruction produce the output pulse for one scan cycle only when there is a change in the input from 0 to 1, that is positive edge. When there is a change in the input from 0 to 1, the OSR instruction going to make output high for only one scan cycle, and after that the output will remains the low unless and until there is again change in the input from 0 to 1. Similarly, the OSF instruction detects there is a change in the input from 0 1 to 0, that is from high to low, then it will produce the output high for one scan cycle and the output will remains the low when if there is a no change from the high to low. So basically OSR instruction detects the positive edge of the input and OSF instruction detects the negative edge of the input. So these instructions are used to detect the change in the event or change in the input from high to low and low to high. For example, if you want to turn on a one motor when there is a push button, press and turn off the motor when push button is released. So in that case, when the push button is pressed, the OSR instruction can be used to detect the change in the input from 0 to 1. So with the help of OSR instruction, we can turn on the motor. But to turn off the motor, we can use the OSF instruction to detect there is a change in the input from 1 to 0. Here the uh, RX Logix 500 software, and I have already connected the Micrologix 1400 PLC. So now this is the OSR instruction at the output and OSF instruction also at the output. I have kept it in parallel. This is storage bit, just I have given one address to storage bit and the another address to storage bit or to the OSF instruction. Now this output bit, that is 10 bit number 10 and bit number 7, bit number 10 for the OSR instruction and bit number 7 is for OSF instruction. Now this output bit we are going to see what it is happening when this input bit number 8 is going to high. At that time the OSR instruction going to make this output 10 bit high for one scan cycle, and when this output bit number 8 turns from high to low, then at the time this OSF instruction is going to make the bit number 7 high for one scan cycle. Actually the scan cycle of PLC is very high, so we will not able to detect when there is a change in the input of in the B7 and B10. So that's why what I have done, I have taken this bit number 10 and I am going to latch the bit number 11 just to see that the bit number is 10 is going to high or not. Similarly, I have used this bit number 7 and then given to the one another address bit number 12, that is latched when there is a bit number 7 is going to high, then this bit is just used to just unlatch the both of these bits. Now I'm going to download this program in Allen Bradley PLC and then we're going to see with actual demonstration. See now this you can see in here all the bits are 0 when I'm going to turn on bit number 8. So when bit number 8 is on, this bit 10 was high for one scan cycle, and because of that, when this bit is high, this bit is latched. Bit number 11 is set to 1. You can see bit number 11 is 1. If I turn the bit 0, then this bit number 11 is also remaining high because this bit is not resetted to 0, or it is not set to the unlatch. Okay, now in this case you can see when the bit 8 is turned to 0, this bit number 7 was set to 1 for one scan cycle, and because of that this bit number 12 is latched. Bit number 12 is high. Now just I'm going to reset both the bit again, and again we are going to see the effect. Now if when that bit number 8 is going to high, OSR instruction is going to make this bit number 10 high, and when this bit 10 is high, then 11 bit is going to latch and it will set to 1. See, bit number 8 is high, then bit 10 was high for one scan cycle, and because of that the bit number 11 was high, is high actually. Now if I am going to make bit number 8 to low, then you can see bit number 7 was high for one scan cycle, and because of that it bit number 12 was is high now. And now I'm going to reset both the bit. So now I hope now you understand the this positive edge instruction and negative edge instruction, that is called as OSR instruction and OSF instruction. These both instructions are used to detect the change in the input from positive to negative and negative to positive.